Ladies and gentlemen, boys and girls, children of all ages, we have covered adding and subtracting fractions. We have covered multiplying fractions by whole numbers. Now we are talking about dividing with unit fractions and whole numbers. One thing you must know is a unit fraction is a fraction that has a numerator of 1. For example, 1/4 is a unit fraction because it has a numerator of 1. Now what we'll be doing is we'll be doing the whole number divided by the unit fraction, or the unit fraction divided by the whole number. So those are the two things we're going to do. Now we also know that multiplication is an inverse operation of division. So we can use that to go through and make sure that we're checking our work and make sure our work makes sense. One of the things I want to emphasize is that if you're dividing the whole number up, your answer is going to be a whole number. If you're dividing the unit fraction up, your answer is going to be a unit fraction. So whatever it is you're dividing up, that's going to be what your answer is in that form. So let's look at this first problem. 5th grade teacher bought a 3-foot long sub sandwich. They cut it into slices that are 1/4 of a foot long. How many slices do they have? What might your first step be to solve the problem? Well, since they give us this picture, my first step would be maybe dividing the sandwich into 3 equal pieces. So this is a foot, this is a foot, and this is a foot. So we have our 3-foot sandwich. We're dividing it into pieces that are 1/4 of a foot long. So we're doing the problem 3 feet divided in it by 1/4. 3 feet divided by 1/4, because we want to know how many 1/4 are there in 3 feet. This is asking how many 1/4 are there in 3 feet. And since we're trying to figure out how many slices do they have, we're not going to have a fraction of a slice. How many slices means the total number of pieces of sandwich. And we can divide that into 4 equal parts. This is 1/4. This is 1/4, this is 1/4, and this is 1/4. So 1 foot has 4 pieces. So that would mean the second foot also has 4 pieces. And the third foot also has 4 pieces. So each of these 3 feet have 4 pieces in them. So if I do 3 divided by 1/4, I get 12, because there are 12 1/4 in 3. So if I just kept dividing, I have 4, 8, 12. There are 12 slices in this pizza. And since I've said they're inverse operation, and well, I didn't just say it, it's a fact, Jack. If we want to do an inverse operation, if I take 12 and I jump 1/4 12 times, that's going to equal 3. So the inverse operation. This is one way we can use to check and see if our answers make sense. Now I will also tell you that when we're dividing, if I take my whole number and multiply it by my denominator, my answer is either going to be 12 or 1/12. And we'll see some others like that. But if you just multiply your whole number and your denominator, you know that's going to be in your answer. So the number 12 is going to be in my answer. If I did 1/4 divided by 3, and this isn't this problem, my answer would be 1/12. If I start with the whole number, my answer is a whole number. If I start with a unit fraction, my answer is a unit fraction. Now, let's say they want to prove it. You don't believe me. Mr. McMurdo makes things up sometimes. He's kind of crazy. We don't know what he's talking about. Well, this slide, they have built it for you. It's kind of hard to see, but they took the fraction pieces. This is one whole, this is one whole, and this is one whole. And they put, just like I divided it up, and they have fourths underneath it. So this one whole here has 4/4, just like the sandwich that we just had. And so they proved it by building the pieces. And this question is asking, how many fourths are there in 3 holes? How many fourths would it take to make 3? Here's another pizza problem. The STEM club was having a pizza party. They bought 4 pizzas and cut the pizzas into slices that were 1/6 of a pizza. How many slices were there? How many slices were there? We're looking for a whole number because it's asking how many slices. It's not going to be how much of a slice did they get. It's how many slices. So we have 4 pizzas. And we're dividing that. Each pizza is divided into 6 equal pieces. And we want to know how many slices that is. And we're going to pretend that these are equal sized pizzas. If we kind of squinch our eyes together, it's like one of those magic photos. So this pizza has 6 slices, which means this one's going to have 6, which means this one's going to have 6, which means this one's going to have 6. So 4 pizzas, and each one has 1/6 piece. They cut them into, each piece is 1/6 of a pizza. And how many slices are going to have? Well, we have 4 times 6. I know it's going to be 24. Is it 1/24 or is it just 24? Well, it's just 24 because it doesn't make sense if you put 1/24. How many pieces are there? 1/24. That's less than 1 piece. That makes no sense whatsoever. Now they also have number lines here. Number lines is another way that they show division of whole numbers and fractions. So if we look at this problem, Mia walks a 2-mile fitness trail. Here's our 2-mile fitness trail, starting at 0, ending at 2. She stops to exercise every 1/5 of a mile. 1/5, 2/5, 3/5, 4/5, 5/5. 5/5 equals 1. 1/5, 2/5, 3/4, 3/5, 4/5, 5/5. And so that one is 1 as well. So this is 1 mile and this is 1 mile. We want to know how many times she stops. We drew the number line from 0 to 2. We divided it into fifths. So each of these lines means a 1/5 of the mile. Our question is, skip counting by fifths from 0 to 2. Find 2 divided by 1/5. My answer is going to be a whole number. 2 divided by 1/5. My answer is a whole number because my dividend is a whole number. And it says to skip count. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my answer is 10. She stops to rest 10 times, or she stops to exercise 10 times. So there are 10 1/5s in 2 holes. So 2 divided by 1/5 equals 10. All right, Roger has 2 yards of string. He cuts the string into pieces that are 1/3 of a yard long. How many pieces of string does Roger have? We would model using 2 whole fraction strips. So I could say 2 whole fraction strips. So this is 1 yard, and this is 1 yard. So for a total of 2 yards. This from here to here, we have 2 yards. And then we want to see how many thirds would fit underneath this. So if you had your poly pad, you would figure out how many thirds would fit under each one of them. Well, 1 yard, I'd have to have 1/3, 1/3, 2/3, 3/3, because 3/3 equals 1. And that's what this whole thing is. So if 1 yard had 3 slices, 2 yards would have another 3, and that would be a total of 6 pieces of string. 6 pieces of yarn. So there are 6 1/3 slide pieces in 2 holes. So 2 divided by 1/3 is 6. 6 times 1/3 is 2. Inverse operations. 2 divided by 1/3 is 6. 6 times 1/3 is 2. Inverse operations, he has 6 slices. If it were multiplication, we could count. If I was doing 6 times 1/3, that means I'm jumping 1/3. 6 times 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, which gives me a total of 2. So that is one way we can check it. This one is a little different. This one is the opposite of the ones that we've been doing, because this time we are having 1/2 divided by 3. So Kalia shares half of a package of clay equally among herself and each of her 2 friends. What fraction of the whole package of clay will each friend get? My answer has to be less than a half. It has to be, because she only has a half to start with. And she's taken that 1/2 to start with, and she's figuring out what pieces would fit equally under 1/2. Well, what would fit equally under 1/2 would be 1/6. So the equation that we have is we have 1/2 divided by 3. I've taken my 1/2, I divided it by 3 equal pieces, and each of these pieces would be 1/6. 1/6, 1/6, and I know that 1/6 plus 1/6 plus 1/6 equals 3/6. So that tells me 1/2 divided by 3 is 1/6. Each person is going to get this much of the package of clay, 1/6. Started with a unit fraction, divided the unit fraction by a whole number. My answer is a unit fraction. If you start with a unit fraction, your answer is a unit fraction. So if we remember that, and also the question, what fraction of the whole package of clay, that should tell you as well. And if you notice, 2 times 3 gives me 6. So that tells me the fraction of it is going to be 1/6. Next, we're going to look at these brownies. Tamira's mom made a pan of brownies, and there was 1/5 of a pan of brownies left. After school, Tamira and her 2 friends equally shared what was left. What fraction of the whole pan of brownies did each person eat? Well, here's our pound of brownies. It's cut into fifths. And there's only 1/5 left. There's only this much left. And we're spreading it equally among Tamira and her 2 friends. So we're splitting this among Tamira and her 2 friends. So we're splitting the 1/5 among 3 people. We're splitting the 1/5 among 3 people. So is each of these people going to get less than or more than 1/5? Well, we're starting with 1/5. This is all gone. We're starting with 1/5. So they're going to get less than 1/5 of the pan of brownies. Less than 1/5. If we look at it here, here's a picture of what we have here. Now we have 1/5 of the brownies left. And she's splitting that equally among herself and 2 friends. So what we're asking, we want to know how much is this slice, and we're comparing it to the whole pan of brownies. How much is that? Well, that tells us I'm going to have a fraction, because I have 3 people and I'm dividing this, and my fraction is going to be less than 1/5 because this whole thing is 1/5. But I want to find out how much this is. Well, one picture that you may see to divide this or to show this is a picture of this. This is what we have. This is all gone. 5 equal slices. This is all gone, probably because I ate it, because I could eat 4/5 of a pound of brownies easily. We're dividing this part into 3 equal sections, but I want to know how much this part is compared to the whole pan of brownies. So they divided this. We have our fifths, but they divided each of the fifths into 3 equal pieces. So we have 1/5. We divided it by 3, and we're going to get 1/15. Why? Because this is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1 out of the 15 pieces. 1 out of the 15 pieces. So they get 1/15 of the pan of brownies. Again, 5 times 3 is 15. So without even looking at what I'm going to do, my answer is going to be either 1/15 or a total of 15. But since I'm breaking up the fraction part, my answer is going to be a unit fraction. Broke up the unit fraction, my answer is going to be a unit fraction. And we can see where these two problems, we have 3 divided by 1/3. How many 1/3s are there in 3? How many 1/3s are there in 3? Well, we have 3 holes here. We count the 1/3s, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this is going to equal 9. This one, we have 1/3, and we're dividing the 1/3 into 3 equal pieces. So here's a third, here's a third, here's a third. So this is what we have left, is 1/3. So we have 1/3, and we're dividing that into 3 equal pieces. Well, if I divided each of these thirds into 3, that would give me 9 pieces. So my answer would be 1/9. I know it's going to have a 9th in it, because 3 times 3 is 9. 3 times 3 is 9. So I got to decide, am I going to have 1/9 as a unit fraction, or am I going to have a whole number? If I divide the whole number by a unit fraction, I get a whole number. If I divide the unit fraction by a whole number, I get a unit fraction. So am I looking at part of a piece? Part of a piece. So taking 1/3 and cutting that into 3 equal pieces like we did here. Or am I looking how many 1/3s are there in 3? And again, the same type of problems here. If we have 3 divided by 1/3. Well, here's 3. 1, 2, 3. Dividing it by 1/3. So how many 1/3s are there in 3? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 divided by 1/3 is 9. Or 9 times 1/3 is 3. Repeated addition. If I add 1/3 together 9 times, I'm going to get 3 wholes. The second problem here, 3 divided by 1/6. I have 1, 2, 3. I divide it by 1/6. Each of these whole numbers is divided by 6. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18. So 3 divided by 1/6 is 18, because 18 times 1/6 is 3, which means if I added 1/6 up 18 times, 1/6 plus 1/6 plus 1/6, and you carry it on 18 times, you get 3 as a whole. Let's look at this one. 1/4 divided by 2. Well, here's my fourth. I'm cutting this 1/4 piece into 2 equal pieces. So 1/4 divided by 2, each one of these is one of the equal pieces. So if I have 1/4 of a pizza left and I have to share it with somebody, I'm going to have each of us is going to get 1/8 of a piece. So 1/4 divided by 2 is 1/8. Because if I'm dividing a fraction by a whole number, I'm going to get smaller pieces, which means 1/8 times 2 is going to give me 1/4. 1/8 plus 1/8 is going to equal 1/4. The inverse operation. I know it's going to be 3 times 6, so my answer would be either 18 or 1/18. Well, since the 3 is first, the 3 is what's being divided. That means it's being divided. There are 18 1/6 in 3. 1/4 divided by 2. We had 1/4. We divided it into 2 equal pieces. That's going to tell me that each of these is 1/8. Because if I went along and I did the same thing, and I divided every fourth into 2 equal pieces, that would mean there would be 8/8, which equals 1 whole. And each one of these would be 1/8. All right, easy peasy, raw chicken squeezy. Let's look at these quickly here. Maya uses 5 quarts of water for her plants. She uses a half a quart of water for each plant. So what are we dividing? The quarts of water. We're dividing the quarts of water. We're not dividing the half a quart of water between everything. We're dividing the total number of quarts of water into groups of a half. How many halves are there in 5? How many halves are there in 5? Well, I know 5 times 2 is 10. Or I could take, this is 1, and if I divide that by a half, 1 whole would have 2 halves. 2 wholes would have 4 halves, so on and so forth. So my correct answer would be A, 10. Chris has 3 granola bars. He divides the bars into 1/4 size pieces. Which picture represents 3 divided by 1/4? Well, we have to have 3 holes. This one has 4 holes. This one has 3 holes. Is each one of these divided into fourths? No. Each one of these is divided into thirds. We have to have 3 holes. 1, 2, 3. Is each of these divided into fourths? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 3 divided by 1/4 is going to be C, and it's going to be 12. There are 12 1/4 in 3. 12 1/4 in 3. Okay, the STEM club was having a pizza party. We already did this one because we know we're dividing the 4 pizzas, and each pizza is going to be divided into 6 equal pieces. So 4 divided by 1/6, they're going to be 24 slices of pizza. A package contains 4 cups of oatmeal. There's 1/3 of a cup of oatmeal in each serving. Are we dividing the number of cups that they have total, or are we dividing that 1/3 a cup between other servings? No, we're going to have 4 divided by 1/3. This is what we start with. So how many 1/3s are in 4? How many people can be served oatmeal if each person gets 1/3 of a cup of oatmeal? How many people? We're not going to cut the people into pieces. So 4 divided by 1/3 would be 12. We could feed 12 people oatmeal. And again, we could do this. 1 divided into thirds. That's 1 cup. And I could do 4 cups, and I'll show you there are 12 servings in 4 cups. So 4 divided by 1/3 is 12. The art teacher had 3 bottles of red paint. She squirted 1/5 of a bottle into each student's palette. How many squirts did she squirt? We have 3 bottles. This is our model. And the first student, she gives 1/5 to, 2nd, 3rd, and 4th. So each student gets this much. We're asking how many students. So we're going to have our division equation is going to be 3 divided by 1/5. How many 1/5 are there in 3? Well, if I kept with my picture, and we're pretending like they're all the exact same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So each student gets this much. So each student gets, there are 15 students. Since each student gets this much, so in one bottle, she has 5 students, another bottle, 5 students, and another bottle, 5 students. 3 divided by 1/5 is 15. The multiplication problem would be 15 times 1/5. So here's 15 times 1/5. Each one of these is a fifth. And so if I do that repeatedly 15 times, I'm going to get a total of 3. So how many squirts did she squirt? She squirted 15 squirts. How many squirts did she squirt? She squirted 15 squirts. All right, so the cafeteria lady had 6 oranges that she divided up into pieces. Well, this tells us we're going to have 6 oranges from my model. We're dividing each of these oranges into 8 slices. So each of them is going to look something like this. And we want to know how many pieces of orange did we have. So we start with 6 oranges divided by 1/8. How many 1/8 are there? Well, in one, there's 1, 2, 3, 4, 5, 6, 7, 8. So one orange has 8 pieces, but we want to know how many 6 oranges has. And that means there's going to be 48 pieces, because 6 times 8 is 48. We're looking for how many of the pieces there are, so that's why we're going to get 48. We'll continue with this and carry on, but I'm telling you, when we take the test, multiplying and dividing fractions is much easier than adding and subtracting fractions. So I'm certain y'all are going to do great on this. Boom, shakalaka, peace out, God bless, love you, do something kind today, save the bees, be a good person.